looking at chapter 4, lesson 6, which is on inverse trig functions. We are going to do examples 1, 2, and 3 today, which look at evaluating inverse sine functions, inverse cosine functions, and then inverse tangent functions. This first slide is important to note whenever you are looking at those values and finding them. There are specific ranges that you have to look at. So for arc sine, which is the first one we're going to do, our range is going to specifically be between negative pi over 2 to pi over 2. For arc cosine, it's going to be between pi and 0. And then tangent is also between negative pi over 2 to pi over 2. This is a lesson where you are going to want your unit circle. You will be able to use your unit circle on a quiz and a test for 4-6. So make sure you have kept up with that. If you haven't, you might want to phone a friend and make a copy of it. So looking at, and the graphs we've already kind of done before, so we're not going to look at the graphs right now. We did those in lesson 4-5. So looking at example 1. Example 1 is all inverse sine functions. So one of the things that we just talked about was that your range has to be between negative pi over 2 to positive pi over 2. So for your unit circle, and I'm not going to draw the entire thing out, but I have pi over 2 right here. Negative pi over 2 would be at the bottom. So whenever I'm answering these questions, the only numbers that I can use are going to be between pi over 2 to negative pi over 2. So in quadrant 1 and then quadrant 4. Because it also has to be in a domain of -1 to +1, that would really lead me to only using stuff in the first quadrant. So I will kind of explain what that looks like as we do each individual question. So as a reminder, your sine value whenever you're looking at your unit circle is your y value in your ordered pair. So that's what we're looking for, is where your y value is what's given. And then your answer is going to be in the radians that are at that point. So for example 1, looking at your unit circle, you are scanning, I would start with quadrant 1. So you're really scanning quadrant 1 and looking at your y values to see which y value has a square root of 2 over 2. So if you look at your unit circle, you will see that at 45 degrees, there is a y value of square root of 2 over 2. Your answer is going to be your radians at that point. So the radians at 45 degrees is pi over 4, which is your answer to this first question. So you're using your unit circle, but also having to look at specific parts of your unit circle. So for the next question, same thing. So this is your, again, y value. So you are specifically looking in your first quadrant to see if there's anything in the y value that's negative square root of 3 over 2. You will notice there's not. None of your y values are going to be negative. So where your answer comes from is, I have a range of negative pi over 2 to positive pi over 2. There's nothing in the first quadrant that is actually equal to negative square root of 3 over 2 in the y value. But if you look at the bottom part of this, so meaning quadrant 4, there is a y value of square root of 3, negative square root of 3 over 2 at 5 pi over 3 or 300. You cannot use that point because it is not in the domain of -1 to +1. So what is going to happen is This line right here is going to reflect up and is really the same line as your 60-degree line. The radian measure at that is pi over 3, but because I reflected it up, I would need to make it negative, so my answer would be negative pi over 3. So again, that came from this y value is square root of 3 over 2. It's not negative. I specifically need it to be negative. This one in quadrant 4 is negative, but it doesn't fit my domain. So in order to kind of think through how I could get that answer, the line at 300 degrees is the same as 60, so it's a reflection over your x-axis. At pi over 3, because I reflected it, I am making it negative. So your last example is asking you to find the exact value of negative pi over 2. This one's relatively simple. Is there a negative pi over 2? So there is a positive, or pi over 2, 2 pi. So there's a positive 2 pi here, which means the negative 2 pi would reflect over and be on this side. If it is on this side, it would be between quadrant 2 and quadrant 3. Because of my range rule, I need it to be somewhere between quadrant 1 and quadrant 4. There's no way to reflect that over in this one. So when it says if it exists, this is one where it does not exist. Okay. The other way you can also think of that is there's no 2 pi y value. Your y value at 2 pi is 1, or actually they're both 0. So your y value at 2 pi is 0. So it's not existent. There's no y value on your unit circle at all anywhere that is equal to 2 pi. So that is your answer for inverse sine functions. Then looking at inverse cosine functions, you're really doing the same process. Your domain is also -1 to +1, and then the range that you're looking at is 0 to pi. So now 0 is here, pi is here. So I'm looking for stuff specifically that are in quadrant 1 and quadrant 2. So if it happens to end up in quadrant 3 or quadrant 4, you're going to have to reflect it over and make it negative, like we did in example B of the last one. So remember that cosine is now your x values in your ordered pairs. So you're looking for the same thing. So for this first one, you are finding the x value between 0 and pi that equals 1. So looking at your unit circle, there is an x that equals 1 on this ordered pair, which the degree measure, their degree measure is 0. The radian measure would also be 0 for this specific question. So we're specifically looking at this side of the line because it is quadrant 1 and quadrant 2. I know that that same line is also 360 or 2 pi, but 2 pi is really on the bottom of that and would go with quadrant 4, not quadrant 1. So because I'm starting at the top and going over, my radian measure would be 0. So your answer to part A is 0. Part B, again, same thing. I'm trying to find my x value in quadrant 1 or quadrant 2 that is equal to negative square root of 3 over 2. So if you are scanning your unit circle, you are looking for an x value that is equal to negative square root of 3 over 2. Whenever you scan that at the degree measure of 150, there is a x value that is negative square root of 3 over 2. The radian measure that corresponds to that is 5 pi over 6, which would be your answer. Then for the last one, you're going to scan your unit circle and see if there are any x values that equal negative 2. If you look at your unit circle, there are no x values that equal negative 2, so your answer is that it does not exist. So, same thing as the sine ones. Sine is y, cosine is x. Same concept, you're really just scanning. The biggest thing is knowing your range of where you have to look versus where it can be and where it can't be. Then for example 3, you are evaluating inverse tangent functions. So tangent becomes a little bit more difficult because tangent is not given to you on your unit circle. You had to find it whenever you did your unit circle project. But remember, tangent is your y divided by your x value. So you would have to figure out which of your values is going to give you square root of 3 over 3. So I automatically know it's going to either be pi over 3, which is 1/2 square root of 3 over 2, or it's going to be pi over 6, which is square root of 3 over 2, 1/2. If I were to actually divide these out, meaning I did square root of 3 over 2 times 1/2, I would have to multiply by the reciprocal, and this would just end up being square root of 3. Whenever I do the math for like pi over 6 or 5 pi over 6 or any of the ones that start with square root of 3 over 2, and I divide this out and then multiply by the reciprocal, this is the one that would leave me with square root of 3 over 3, which is what I am trying to find. Okay. The reason I know it's not pi over 4 is I would have square root of 2 over 2 divided by square root of 2 over 2. I'm dividing the same thing over the same thing, which would give me ultimately 1. Okay. Your range for your tangent value is the same range as it was for your cosine value. So it's negative pi over 2 to positive pi over 2. So again, you're looking at quadrant 1 and quadrant 4. I don't know why I wrote 2. So you're looking from here to here. So this is your negative pi over 2 and positive pi over 2. So I'm only looking at quadrant 1 and 4. So your tangent value is positive, and this you do have on your unit circle that you kind of labeled on the 4 corners. The place where tangent is going to be positive in either one of those quadrants would be quadrant 1, because everything is positive. So if I divide a positive by a positive, I'm going to end up with a positive, versus looking at quadrant 4. If I have a negative divided by a positive, I'm going to end up with a negative number. This is a positive square root of 3 over 3, not a negative square root of 3 over 3. So kind of having already done the math over here, your answer would then be pi over 6. So pi over 6 is the place where when I actually divide it out, I'm going to get square root of 3 over 3. And it is in for the first quadrant where tangent is positive, and that value is going to give me what I'm looking for. Then looking at part B of this, it says find the exact value of arctan 1 if it exists. So we already know it's not pi over 3 and it's not pi over 6. If I look at pi over 4, my ordered pairs at that point are square root of 2 over 2 and then square root of 2 over 2. If I were to actually do the math and divide those out, if I have a number divided by the same number, my answer is always 1. Again, tangent is positive in quadrant 1. If I were to have looked at quadrant 4, quadrant 4 tangent is negative because it would be a negative divided by a positive, which is going to give me a negative. And this is specifically asking for you to find a positive 1. So tangent is positive 1 at pi over 4. So that is it for examples 1, 2, and 3. You're really using your unit circle. Your answer is always going to be in a radian measure. You're, again, for sine, looking at y values. For cosine, looking at x values. And then for tangent is where you actually have to do a little bit of math to be able to find where that's going to be equal. So whenever you divide them out, your tangent values are either going to be square root of 3 over 3, 1, or just square root of 3. And that is it.